Dear students, we'll continue our lessons. This is practice 1 on Higher Mathematics 2 course. Today's theme is practice on functions of several variables. Let us continue. As we mentioned in the lecture, real-world functions of several independent real variables are defined analogously to functions in the single variable case. So we remember this one in the lecture side. And here are the examples that we saw in our lecture. The first one, z equals to square root of y minus x squared. This one like z equals to y minus x squared. In this case, in order to find the z's domain, we have to find that y minus x squared must be greater than or equal to 0. So from here, y greater than or equal to x squared. This is the domain. And range itself also here from 0 to infinity because we have square root. In the second case, 1 over xy in the denominator, so xy cannot be 0. Multiplication cannot be 0. This is the domain. Third case, sine of xy. Sine function itself is defined everywhere, so we can choose any x and any y as a degree. But the range for sine function is from -1 to 1. We know this. And there are some other functions of 3 variables. The first one and the second one are similar with the previous example with functions of 2 variables. But the third one here, look here, xy ln z. xy, I can choose any x, any y, because there is no square root, no 1 over, so any number can be here, even 0 also. ln z, but z in this case must be positive, because here we have ln, which is natural logarithm. In the second case, in this one, these 3 numbers cannot be 0 at the same time. We saw this all in the lecture. And here the example, it says to us, describe the domain of the function. This is given function. F of xy equals to square root of y minus x squared. We just have found that its domain is y greater than or equal to x squared. We have found in the previous page, and we know what is y equals to x squared. Y equals to x squared is this parabola. This parabola is y equals to x squared. And it says y greater than or equal to x squared. Look here, y greater than or equal to. It means upper part of this parabola, this part is the domain. This is boundary points as we said in the lecture, and this part outside of parabola, it's mentioned here, y minus x squared less than 0, which is y less than x squared in this part. This is y equals to x squared. This part is y greater than x squared. So we have the domain, we already sketched the domain. Now next exercise says graph f of xy. This is given function 100 minus x squared minus y squared, and plot the level curves. F of xy equals to 0, f of xy equals to 51, and f of xy equals to 75 in the domain of f in the plane. So the first question, we have to graph this function. Graph. The domain of f is the entire xy plane, and the range of f is the set of real numbers less than or equal to 100. The graph is the paraboloid that equals to 100 minus x squared minus y squared, and the positive portion of which is shown in this figure. So this one is the surface. This one is the surface of z equals to f of xy, which is 100 minus x squared minus y squared. It gives us this paraboloid. And the level curve f of xy equals to 0 is set of points in the xy plane at which f of xy, which is 100 minus x squared minus y squared, equals to 0. Which gives us, if we take these 2 numbers to that part, we'll get x squared plus y squared equals to 0. This one. which is the circle of radius 10 centered at the origin, which is this one. It has radius 10. The distance from here till there, the radius 10. This radius is 10. So this big circle. And in the second case, it says similar level curve f of xy equals to 51, which gives us 100 minus this expression. If we took this together to another part, they will be positive, and 100 minus 51 gives us 49, which is the circle again, with the radius of 7. This point is 7 now. And in the third case, the number was 75. 100 minus 75 gives us 25. This one. This is also a circle with the radius 5. This point is 5. How we identify that this is a circle? We know its formula from the previous courses, from the Higher Mathematics 1 course or pre-calculus courses. And we also can identify and try to graph them, finding y from here. We'll get y squared equals to 25 minus x squared, and here y equals to plus or minus square root of 25 minus x squared. And this is 2. So this gives us 2 half circles. Y equals to square root of 25 minus x squared gives us this half circle. The other part gives us this kind of, oh sorry, it's not that clear right now. It's hard to draw a circle with this one here. This kind of and this kind of. Okay. In the next exercise says describe the level surfaces of the function f of x, y, z, which is square root of x squared plus y squared plus z squared. This is the given function. The value of f is the distance from the origin to the point x, y, z. Each level surface of this function, which is the function equals to c, and the c is positive number of course, is a sphere of radius c centered at the origin, which is the origin is this point, center, the point O. Figure shows a cutaway weave of 3 of these spheres. The level surface of this function when it's equals to 0 consists of the origin alone. This point also level surface. The point O also level surface for this function. And we'll try to identify, to imagine the 3 level surfaces when c equals to 1, when c equals to number 2, and when c equals to number 3. We are not graphing the function here. We are looking at level surfaces in the function's domain. Why? Because we have 3 variables, x, y, z. And also we have a function, which is in this case we may say w. So 3 independent variables, 1 dependent variable. How many variables? 4. That's right, 4. If we try to graph this one, we'll have 4D graph, 4-dimensional. 4-dimensional. But it's hard to imagine for us. So we'll not graph the function. Try to draw its level surface. If we remain on a sphere of radius c centered at the origin, the function maintains a constant value, namely c. If we move from a point on one sphere to a point on another, the function's value changes. It increases if we move away from the origin and decreases if we move toward the origin. The way the values change depends on the direction we take. The dependence of change on direction is important, of course. And we may see here 3 functions. When this expression, the function equals to 1, we'll get this small level surface. And when it's equals to 2, we'll get this second level surface, which is gray here. And when it's equals to 3, we'll get this pink level surface. Let's try to solve some simple exercises on the functions of several variables. And the first exercise says f of xy equals to x squared plus xy cubed. Okay. Find the specific function values. This is a function and this is specific value. We have to find f of 0, 0. What is this 0? The first 0 means x. The second 0 means y. Okay, now it means I have to put 0 instead of x and 0 instead of y also. Okay, let me try. 0 squared plus, instead of this I'm putting 0, times, instead of y I'm putting 0 also, 0 cube. 0 squared will be 0 plus 0 times 0 cube, 0. So the answer is 0. Oh, that's fine. Next question. F of xy equals to sine xy. This is a function, given function. I need to find, okay, f of 2 and pi over 6. Okay, what is this? It's a little bit different than the previous one. Yeah, the first one till this comma, this is x again, and this one is y. Okay, now it's clear. Let's write down here sine function. Instead of x, I'm writing 2. And if there is nothing, we'll think there is a multiplication sign, times pi over 6 equals to. I have here 2 and 6. They are gone. And I will get the number 3 in this place. Okay, let me continue. Then I will get sine pi over 3. Okay, sine pi over 3 is 60 degrees. What is the value of sine at 60 degrees? It's less than 1. It's less than 1, and I think, yeah, it's square root of 3 over 2. This is the answer for the second question. Given a function of two variables, and we identify the specific function values, which is f of 2 and pi over 6. Let's move further. Find and sketch the domain for each function. So we have just one function here. First of all, try to find the domain. Given function, it is square root of function, so the expression under the root must be positive, maybe 0. Y minus x minus 2 greater than or equal to 0. Y, let's take this to another part, greater than or equal to x plus 2. Okay, this is the domain. I have found its domain. This is the domain. I have found its domain. Now it's time to sketch the domain. Let me try to draw some coordinate plane here, because I will need coordinate plane in order to draw the domain. Okay, let me start from this point here. Oh, sorry, something went wrong. Oh, again, sorry. Sorry for this, because it's my almost first time using this device. It's okay. Okay, finally I have a coordinate plane here. So how to sketch the domain? Let me think. Oh, it's a linear function, which is y equals to x plus 2. I need to graph this function here. How to graph it? We have x's and we have y's. When x equals to 0, put 0 here. 0 plus 2 is 2. Y equals to 2. When y equals to 0, x equals to negative 2. Okay, I need these 2 points. It's enough. This one will be x in our case, and this is y. So when x equals to 0, y equals to number 2. It's 1 here and 2 here. So this is gonna be our first point. When y equals to 0, x equals to negative 1 here and negative 2 here. These 2 points. Okay. Now I have to connect these 2 points with it. Now I have to connect these 2 points with each other. Let me choose another color here. And Okay. Okay. Smooth graph. Y equals to x plus 2. What do I need here? I need y greater than or equal to x plus 2. Which part? What do you think? Yeah, it's this part. This part. Here y greater than or equal to x plus 2. So inside is that part, and this part y less than or no, not equal to. Find the domain. This is domain, and this is the graph of domain. Next exercise. Find and sketch the level curves f of xy equals to c on the same set of coordinate axes for the given values of c. Okay, first of all, how to find the level curve? Do you know it? Do you know how to do this? No. But I know. I'll help you. Okay. We have here f of xy equals to c. I have here f of xy equals to something. This is a function. And c equals to -3, -2. Okay. Here are all c's. Let me write this expression. X plus 1. Instead of f of xy, I will copy this here. And it's equal to c. Instead of c, I'll take -3 first. -3. So this one gonna be, okay, let us, y is here equal to -1 there. 1 minus 3, it will be positive, right? -3x. Okay, so this is gonna be y equals to -2, -x. This is the first level curve. Let me change the color. And next one, x plus y minus 1 equals to -2. Y equals to -1, -x. And in this way we'll find the others also. X plus y minus 1 equals to -1. Y equals to +1, -1, 0, -x. Okay. Next one. X plus y minus 1 equals to 0. Y equals to x there, 1 there. Okay, 1 minus x. It was this one. And the next one is 1. So y equals to 2 minus x. When we choose number 2, we'll get y equals to 3 minus x. And finally, when I choose the number 3, this one, I will get y equals to 4 minus x. You can do these calculations on your copybook. Okay. Again, coordinate plane. It's my hard point. I'm not a painter, I'm not a drawer. Okay. Sorry. This is gonna be y and this is gonna be x. Let's start from the first one. Maybe it was this. So when we choose -3, I got this one, y equals to -2, x. So when I plug in 0 here, I will get y equals to -2. When x equals to 0, y equals to -2, -1, -2. This point, and y equals to 0, x equals to -2. -1 for x, -2 for x. This point. Okay, we have 2 points now. And try to connect them. Sorry. That's gonna be fine. This is first level curve, and next one. Y equals to -1, -x. When x is 0, y equals to -1. This point is 0, x equals to -1. It's that point. So connect these points together and have fun. These two lines should be parallel. In my case, it's not shown. The next one, y equals to -x. When x equals to 0, y is 0. This point, when x equals to 1, y is -1. When x equals to 1, y is -1. Okay, come here, this point. Connect them together again. Okay, we have to think that this is the point, and now let me write down here. This is y equals to -x, y equals to -x, and the black one, y equals to 1 minus x. When I plug in 0 here, y is 1. When x is 0, y is 1. When y is 0, x is also 1. This point. Okay. This is gonna be y equals to 1 minus x. And the green one, when I plug in 0 here, I will get y equals to 2. Find the number 2. When I plug in 0 there, x will be 2. Okay, this point. Y equals to 2 minus x. Next one gonna be y equals to 3 minus x. It will be 3 and 3 there. So this will be a level curve also. And finally 0.44. Okay. Yahoo! 4 minus x. These are level curves. When you draw on your notebook, on your copybook, you have to draw this carefully. You will get like several parallel lines. This is the answer. This is the answer for this question. Find and sketch the level curve. Find. The first part. Find. We have found them. First, second, third, fourth, sixth, seventh, fourth, fifth, sixth, seventh. Yeah. And then we sketch them. Next exercise says, find the function's domain. Find the function's range. Describe the function's level curves. Find the boundary of the function's domain. Determine if the domain is open region, a closed region, or neither, and decide if the domain is bounded or unbounded. So what is the function? Function is this one, exercise. Says as this function given f of xy equals to y minus x. Okay, the domain, the question to y minus x. Okay, the domain, the question A. Domain. Can I plug in here any number? Of course. How about here? Yeah, sure. There is no square root. There is no fraction, no logarithm. So domain is entire plane, entire xy plane, find the function's range b, range. The range gonna be, so if the domain is entire plane, range also entire real numbers, all real numbers. Okay, and exercise C says we have to describe these functions' level curves. How to find level curve? We just saw in the previous example level curve. So we'll need some number C. Yeah. So f of xy equals to C. Using this one, we can describe its level curve. Let's say C equals to -2, 0, +2. Not comma, it must be equal to. Equals to. Okay. The first one, y minus x equals to -2. Y equals to x minus 2. Next one, y minus x equals to 0. Y equals to x. X equals to number 2. Y equals to x plus 2. We have found 3 level curves and we need to draw them. Draw these level curves. Okay. Draw these level curves. This is gonna be x, this is gonna be y, and this is the point 0. Okay, the first one, y equals to x minus 2. Y equals to x minus 2. When I plug in 0 here, instead of x, I will get y equals to -2. -1 for y, -2. The point. When I plug in 0 there, I will get x equals to 2. 1, 2. This point. This point. And this point. Oh, sorry. We don't have this part. Okay, y equals to x. With black one, y equals to x. It should be somewhere here, like this, and like this. Okay, the last one, y equals to x plus 2. When I plug in 0, I'll get y equals to 2. 1, 2. When I plug in 0 there, I will get x equals to -2. X equals to -1, -2. Okay. And there. This is gonna be y equals to x plus 2 graph of, and this is gonna be y equals to x minus 2. And finally the middle one, y equals to x. Okay. We have done with the third question. Now, D. Find the boundary of the function's domain. As we said, the domain is entire xy plane. This is x. Do not confuse them. XY plane. So, domain has no boundary. D. No boundary. E. Determine if the domain is an open region, a closed region, or neither. E. Domain is open, closed, or neither. When we call it open, when it has a boundary, but boundary is not included in the domain, we call it open. When it has a boundary, but boundary is also included in the domain, it calls closed. So domain is not open, not closed. Decide if the domain is bounded or unbounded. If domain is not bounded, unbounded, because domain is entire xy plane, it has no boundaries, so it's unbounded. So that's all for today. Good luck, guys. See you.